All right, so before we go on to the next example, I want to just talk a little bit about the notation for functions and some of the vocabulary that we use. So when we have two quantities, here we have x and y. We say if y is a function of x, we can say that y is a function of x. That means that y depends on x. There's some relationship between y and x. Or we can say that y is equal to f of x. And we can write that using this function notation. Okay, so we have y, right here we have y. Oops, here we go. Yeah, y is a function of x. Now, like I said before, we may or may not know a formula for f of x, right? We may only be given data, but we can express that there's some relationship between y and x by writing that y is a function of x. Now okay, so x is the input. X is the input to the function. It's also called the independent variable or the argument, and it's an element in the domain. Okay, so it's the input. This f, now f is not a variable. F is the name of the function. Okay, so we're just naming the function. We could call it f or we could call it something else. It's just whatever we want to call the name of the function. And then y is our output. It's the dependent variable. It's a value. It's the value of the function, or it's an element in the range. We'll talk more about domain and range in a few days. So, all right. Now, one thing to note is that these x and y and f, those are kind of arbitrary letters. We can change those letters so that they're more descriptive of the quantities that they represent. For example, in that previous example where we had D representing diameter and C representing circumference. It's just easier to use letters that remind us of what those quantities represent. So just remember those letters are arbitrary. Oftentimes we use x and y and f for the name of the function, but we can change those letters. All right, so let's look at this next example. We're given a function. We're basically given the formula for the function, right? So we have f of x is equal to x squared minus 1. Okay, so it looks like we're assigning a variable y to be that function of x. And since we have a formula for it, we can compute the values for y, which is f of x. So let's do that right now. Let's go through this first one together because there's something I want to point out. When you replace the x, so we're going to replace x with these values, I would suggest putting parentheses around whatever you replace x with. So I'm replacing x with minus 2. So I'm going to put 2 in parentheses before I square it. Okay, because I want to square minus 2. Okay, and then subtract 1 from it. Okay, so when I square minus 2, I get a positive 4, and then I subtract 1 and I get 3. So the value of the function for x equals minus 2 is 3. And the reason you have to be careful about that is because if you put this in your calculator, let's say you type into your calculator minus 2 squared minus 1. You could try it. See what happens. It's going to give you minus 5, which would be wrong, okay? Because your calculator thinks that you just want to square 2, but you actually want to square the whole value of x, okay? So if you, when you do that, right, if you square the whole value of x, minus 2 squared means minus 2 times minus 2 minus 1. And minus 2 times minus 2 is a positive 4, right? Negative times negative is positive, and then we subtract 1. Okay? So like I said, I would suggest putting parentheses around any time you replace x with some other value. You want to put parentheses around it, right? Because you're going to square the whole thing. All right. So let me just compute these values. All right, so there you go. Oops, I was missing my 0 here. So there's all of the values computed. All right, so now we're going to take those values and show them as on a graph. Remember that this is our independent variable, right? Independent, can't spell today. All right, independent variable. All right, so I'm going to put it on the horizontal axis. It's my input, right? It's the input. So I'm going to put the input on the horizontal axis. Input goes on the horizontal axis, and so the output, which is y, output, that goes on the vertical axis. All right, I need to, now this, I have a grid over here, which is nice, but I don't have any scale, I don't have any axes shown. So you have to decide, how do you want to space things out? It looks like our x goes from -2 to +2, so I would probably, so x is going to be on the horizontal axis, so I'm probably going to put the y-axis right down the middle. Whoops. So we're going to do this nicely. Put it right down the middle. And so that I'm dividing the x-axis in half, right? So 0 is going to be right in the middle. And then it looks like my y values go from 3 to -1. So it looks like I can bias it down. Maybe I'll put the x-axis here. Okay, so I'm going to call this the x-axis and call this the y-axis, right? I'm always going to put the independent variable on the horizontal axis and the dependent variable on the y. All right, so now I can just plot these points. So I gotta have a scale on here too. So make sure when you're drawing these graphs, put some sort of scale, otherwise it's meaningless to me, right? So I'll just make each grid worth 1. Now you might make the assumption that, you know, if I see a graph and it doesn't have a scale, I might just assume that each grid mark is 1, but it's not always the case. So you have to have a scale. So this would be 2 and this is going to be 4. You don't have to mark every single tick mark, but you need some sort of scale. All right, so now we can start plotting the points, right? Now that we have a scale. So -2, we're at 3. At -1, so that's going to be here, we're at 0. At 0, we're at -1. And then we're back at 0. And at +2, we're at 3. Okay, so now I've got these points plotted, right? So these are our x and y coordinate pairs, right? So this represents 2, 3, a coordinate pair. And then I can just connect up these dots, right? I'm just going to draw a curve between these dots, right? So as well, like I said, I can do it with this pen is slippery and it makes it hard to draw nice smooth curves. But so there you go. There's a graph of this function f of x equals x squared minus 1.